all the decisions we took three decisions: optimistic, pessimistic, opportunistic, or conservative. Okay. Now, those decisions we took, we did not attach probabilities to the state of nature. Now, we only told you that the state of nature was good and bad. Did you remember? That's it. It was good, it was bad. But how do you know that some state of nature is good or bad? What is the probability? Because all of these things have not happened. These are things that are going to happen. What is the probability that the state of nature is going to be good? What is the probability that the state of nature is going to be bad? So we need to attach probabilities to the future state of nature. We need to assign probabilities to them. And this is normally possible if you get an economic forecaster, if you get an economist who will tell you the future event. And we have a lot of people who can tell you the potential treasury rate, the potential interest rate, the prime rate, and all of that. We got, lots of people who are doing stock analysis. Now, if we have assigned probabilities, then we are going to use, this time we are not going to use those criteria anymore. We're going to use two different criteria to come out with our solution. And those two criteria are what we are going, they are all probabilistic decisions. The first one, we're going to now make a decision. We're going to make a decision which is known as expected value. We are going to calculate the expected value under each decision alternative. And then we're going to calculate that expected value without perfect information. Now, what this means is that the economic forecaster may have done a forecast, but that forecast wasn't that all perfect. Okay. And now we are going to look at a situation where the forecast was also what? Perfect. So one is without perfect information. That's expected value. And that's called expected value approach. And then there's one which is with perfect information. And based on the without and the weight, we can now calculate expected value of perfect information. Now, let me rewrite these for you to have a look at it. Okay. So we're going to calculate expected value. Let me just do that again. We're going to find expected value without perfect information. Okay. Then we are going to find expected value with perfect information. And then finally, we are going to calculate the expected value of perfect information. It's off. So that one, we don't bring that off. Now, what is the expected value of perfect information? It is the expected value with perfect information minus the expected value without perfect information. You will come to understand each one of them. But for now, we're going to use this approach and calculate the expected value, okay, without perfect information. Without perfect information means that you are still going to use probability. Okay, you're going to use probability. And so let's look at, and we're going to decide with this. It's very important to understand that. We're going to decide with this expected value, okay, with perfect information. We're going to decide with, just like the others where we have been deciding with. Okay. So let's proceed and look at how that is. There's a formula for calculating the expected value with perfect information. Now, first of all, you know that the probability is always between 0 and 1 inclusive. And the total probability is 1. That's what you see all here. The sum of the probability of the state of nature. The S is the state of nature J. So the J can change to 1. If the state of nature is the first one, J can change to 2. If the state of nature is the second one, and on and on. Okay. The sum of these probabilities of this each state of nature is equal to 1. Now, the expected value without perfect information, which will shorten it as expected value approach. That is the formula for that expected value approach. It's a very, very simple formula. I won't lie to you. Let me just give you an idea of what it entails. Okay. This expected value Weight preferred information. Now, what it means is this. It means that take each decision alternative. Let's say decision alternative 1. And then what I'm going to do is that if you look at this VIJ, the VIJ refers to that value, the original value, not a regret table, the original table. Okay. And then you multiply that value by the probability of the state of nature. That's it. You multiply that by the probability. So let's say that that first figure, okay, that first figure was 50,000. Was it 50,000? The first figure for apartment building, okay, that was 50,000. Okay. I just don't want to guess too much. I want to go back. Yeah, that's it. At the top left, that's 50,000. Okay. So you now, let's assume that is 50,000. So if I were to calculate the expected value, okay, if I were to calculate this expected value for that decision alternative 1, which is an office building, this is going to be 50,000, okay, times that probability we will be given, okay, plus the next value there was 30,000. So you'll be 30,000 times that probability that you'll be given. Then you sum it, then you get the expected value for that decision. It's as simple as that. Okay. Now, let's go to where the probability comes into the picture. Okay. Let's go to where the probability comes into the picture. Now, to get to the probability of the state of nature, okay, to get there, you will be given that probability. Okay. You will be given. So look at the storyline here. Using the real estate example, assume that based on several economic forecasts, EVwPI was able to estimate that 60% probability that good economic conditions will prevail. So you were not given anything about bad economic condition, but you were told that there's a 60% chance that economic conditions will be good. So we can calculate. So this is a probability of the state of nature 1. Okay. So it means that what this means is this. It means that the probability of state of nature 1 is going to be what? 0.6. The probability of state of nature 2 will be what? You can tell me. The probability of state of nature 2 will be what? Let me see some of the answers. Okay. What would be the probability of state of nature 2? By the way, how many states of nature did we have? How many states of nature? We had only 2. So the probability of state of nature 1 is 0.6. What would be the probability of state of nature 2? What would be the probability of state of nature 2? It will be 0.4. So the probability of state of nature 2 is calculated as 1 minus the probability of all the others. And in this case, it was only 1. Okay. So that will be 1 minus 0.6, which will give you what? 0.4. I mean, this one you don't even calculate. And let me give you a trick. Always, you will not be told of one of the probabilities. Always. You will not be told of one of the probabilities. And it is your job to be able to use the rest to find that one. Because once you know the rest, you sum them, subtract from 1, and you will know one of the state of nature. So you can be told the probability of state of nature 1, state of nature 2, state of nature 3, state of nature 4, state of nature 5, but you will not be told the probability of state of nature 6. You will not be given that. What do? Well, all you do is that sum those other probabilities, sum them, and once you've been able to sum them, you subtract from 1, and that will give you the probability of state of nature 6. Does that make sense? Fantastic. So on the basis of that, we know that the probability of state of nature 2 is 0.4. Okay, so with that in mind, let's go and calculate. I almost showed you the answer, but let's go and calculate our expected values. Okay. So the first thing we are going to do is this. And remember, we are using this table. The table I told you to write long ago, this table, okay, that table up here, that is what we are using. Okay, so don't forget. We are using the value, the value probabilities. Okay, so we are now going to find the first probability. So it's going to be expected value of D1. Okay. I don't know why this is not looking. Equal to, then you are going to now sum the price. So you take the state of nature 50 times the probability of that state of nature 1, which was 0.6, plus 30. And where am I? Somebody will ask me very soon, where am I getting the 30? The 50 and the 30 are those here. Okay. They are those here. I'm picking them. So I take the 50. So I will actually put 0.6 on top of this and then 0.4 on top of this, just to help me. So you do the 50 times 0.6 plus 30 times 0.4. Then you come and do the 100 times 0.6, then negative 40 times 0.4. Then you come and do blah, blah, 30 times 0.6, then 10 times. That's it. You calculate for each one. Then you sum them and get. So I'm doing the first one, do the other ones. Okay. So this will be 30 times 0.4, which is the probability. What value will you get? What value will you get for the first one? Who has been able to find the answer for the first one? I want you to go ahead and find the expected value without perfect information for D2. Okay, for D2. And I also want you to do the same thing. Expected value for D3. So D1, what was the answer for D1? Excellent answer. Somebody just cracked the code. Eh? Renee, she's done some justice to it. So the first one is 42. Do that. Calculate the second one. Do some. Your colleagues are doing it. You got to do some. And Bertha, she got the correct answer, which is 44. The last one. Do some, because that is the only way that you can do well. It's a form of mastering the skills. Mathematics is an art. Okay? It's an art. So you need to be able to crack those out. Okay? Somebody told me the last one is 30. That's wrong. Okay? The last one is not 30. I need a first person who will give me the last answer. Give me the last answer. Calculate it. Be part of the show. Do it. You know, be honest with yourself and do it. That is 22. Okay. I know somebody just stopped these ones and rather went to calculate that last one. The person went to calculate the last one because he feels that that last one is what is important. Okay. So you've gotten the expected value approach. You've gotten the expected value without perfect information, and you've been able to use it to calculate for each expected value. So based on this expected value approach, that's the question. Okay. Question will always ask you that, based on this expected value approach, which decision criteria will be recommended? Which decision criteria will be recommended? Remember, these are values. These are values. These are benefits. Okay. The recommended decision will be what? Office building, D2. Office building, D2. Now, if you can remember very clearly, apartment, which was D1, has won twice. And office building, which is D2, has also won twice. Okay. So you should note. Let me just remind you. When we're using the Maximax approach, we were able to select this. Okay. That was D2. The maximum, we were able to select the 30. Then the minimus regret. Okay, the 30 was D1. We selected a 50, which was D1 again, apartment building. And now with the expected value approach, we have selected D2. So it's two against 2. So the battle is between apartment building now and office building. Warehouse seems to be uncounted. Warehouse is not winning any selection. Okay, so keep that in mind. Keep that in mind, and then we can now proceed with all the things. That's it. Oh, by the way, when you work it out, you get this. This is what you all did. And you're going to realize that the best decision is office building. And this is what we call the expected value without perfect information. Now, please note that the 44, okay, does not mean that, 44 will result anytime she buys the office building. That's how she's going to get it. But it means that on average, okay, that will be the payoff. Okay. That will be the payoff. And please also know that if these things have been negative, if they have been cost, okay, had the payoffs been cost, then the best decision will be the one with the lowest expected value and not the highest expected value. So please note, we are considering these things as, profit, revenue. So that is why we're using higher or higher. All right. Now let's go to when do we bring the weight perfect information into the picture? It's a very simple one. It's a very simple one. The expected value weight perfect information is calculated differently. In fact, we don't use that to decide. I want to repeat. Okay, we've just calculated. This whole thing we've calculated is expected value without perfect information. Okay. But I'm saying that if we go to the point of calculating expected value, with perfect information, okay, this expected value with perfect information, we don't use it to decide. We use it to help us to get somewhere. And that's what we're going to do. Where is that somewhere? We use it to help us to arrive at somewhere. And let me tell you why we need to understand this. I made a decision without perfect information. So I can buy perfect information. You know that. I can buy information about the future. People buy information. In fact, information can be very, very powerful in business and even in government. Okay, sometimes the government is aware of something the opposition is not aware. The opposition gets to know what the government is aware. They can use that to blackmail them. In politics, somebody can kill somebody, an eyewitness will have that information on a tape. The information has been put on a pen drive. Okay? People will fight, kill for that information. Information is super. We are in the world of information superhighway. The internet gives much information. Your whole life can be put into an information system. There is an information asymmetry, but there's also a lot of information symmetry for some people. So you can buy information so as to make better decisions. Now you can hire an economist to correctly determine the economic conditions will occur in the future. You want that economist to tell you that I mean it. I want you to tell me the exact economic condition that's going to occur. It's not like there's a probability that 60% of the time, we are going to have good economic condition. No, this is somebody that if it doesn't happen, he loses everything. But here's a case. Here's a case, and I need to show you something here. Okay. Here's the thing. You will not pay more for this information. You won't. Okay. You won't pay more for this information than you will gain from it. Do you agree with that? So somebody is giving you an information. The information is going to, with that information, you're going to make $1 million. And yet you are paying the person $2 million for the information. I mean, what is that for? So you will surely not want to pay more than the value that you will gain had you used the information. So the information has some maximum limit value. It has a limiting value, okay, which you, the decision maker, you are willing to spend. the value of that information, the value of that information is what is known as the expected value of, not weight, but of perfect information. So the expected value of perfect information is the value of the information that you are collecting from somebody. So that means that you will pay that person an amount equal to the value of the information he's giving you. Keep that in mind. But before you can get that expected value of perfect information, you need to get the expected value with perfect information. It is with perfect information, but it's not of perfect information. Now, why is that so? Well, first of all, you have been able to calculate the expected value of each of the decision alternatives without perfect information. Okay, so I calculated it without perfect information. Okay, now if I know the perfect information, if I know the value with perfect information, then I will be able to find the value of perfect information. I will pay that person. Okay, and that is what we are going to look at. So the first thing we're going to look at now is to compute the expected value, okay, of perfect information at the decision under each state of nature. Okay, we need to do something. Okay, so if we could obtain that perfect information, okay, then we'll be able to calculate the rest. So let's make this assumption. Each decision outcome obtained using perfect information must be weighted irrespective of the probability. Irrespective of the probability. Okay. And this is important. So here's the thing. Forget about the maximum and the minimum. Throughout this course, we'll be using more of the maximum. Okay. So I want you to understand something here. This thing might look like very, very complex, but to be honest with you, it's not complex at all. It's not. So look at this. The expected value of a weight perfect information under maximization is simple. You would take the probability. Okay, so the probability of the state of nature is. Now, probability of the state of nature 1 was 0.6. And the probability of state of nature 2 was 0.4. Do you remember? Okay, so this is how you're going to calculate it. So for state of nature 1, S1, its probability is 0.6. For state of nature S2, its probability is 0.4. Now, what you are going to do is that you remember the maximum values that we selected, which we were able to use to calculate the regret. You remember the maximum value for the state of nature 1 was 100. Do you remember? And the maximum value for, state of nature 2. The maximum value for state of nature 2, do you remember the maximum value? Who remembers it? Who remembers that maximum value in that column? For state of nature 2. Do you remember? Can you type it for me? That was 30. Very good. Yes, it was 30. Okay. So that was 30. Now, the expected value weight or given perfect information is simply multiplying these values with the respective state of nature, the maximums. Okay. Because the reason why they are said to be weight perfect information is that there is a maximum value you are using. Okay. And so you do the 100 times the 0.6 plus the 30 times the 0.4. That is how you do it. And that will give you the expected value with perfect information. So the expected value with or given perfect information, we don't use it to make a decision. We are only calculating the value with perfect information. That's it. The value, okay, with perfect information. The maximum value you're going to get with perfect information. And to be honest, with perfect information, you can get a maximum value. That's the point. With perfect information, you can get the maximum value. That's why. So you just multiply the maximum value by the respective probabilities. What do you get? Who was calculating? What do you get when you do that multiplication? 100 times 0.6 is 60. So you get 72. You get 72. Thank you. So this is the expected value with perfect information. And that's it. By the way, if you go and check the slide, you'll see that that is all that we did. So that's it. That's exactly the way you calculate the expected value with perfect information. Now, if you don't get this, quickly let me know, because this is the easiest part. So this what we just calculated, that's what is down here. Expected value with perfect information. Now, do you remember we had expected value without perfect information? Okay. The expected value without perfect information was the answer we got by selecting the D1. Now, let me just, by selecting D1, D2, and then D3. We calculated their expected values, and we had one to be 44. But I think we had the first one to be 42, 44, and 22. Do you remember? Okay. So those were the expected value, but then the one without perfect information, this was the one without perfect, and we selected D2. Do you remember? So D2 was expected value without perfect information. So D2 is like expected value without perfect information. So keep that in mind. All right. So now we have what? Expected value with perfect information. So now can we calculate the expected value of perfect information? And if you can remember, I told you that it is given as EVPI, expected value of perfect information. And do you remember what I said that was equal to? If you can remember, I indicated that it is the with perfect information minus the without perfect information. The expected value with perfect information. Now with perfect information, we now know that to be what? 72. So that is 72. Minus the expected value without perfect information. And based on our earlier expected value approach, the without perfect information was 22. So when you do 72 minus 22, the expected value with perfect information, of perfect information, is 28. Fantastic. Finished. What does that mean? Who can tell me what this 28 really means? What does this 28 mean? Okay. What does it mean, really speaking? Let me just take you to the 28. What does that mean? This 28, by the way, should always, okay, so let me give it to Renee. What does that 28 technically mean? Yes,
okay, it's fine. Because when you were solving, you wrote 72 minus 22 and I was confused. Okay, that's fine. Thank you, sir.
All right, so what does the 28 mean? Do you remember I told you that if we were to buy something from someone, if you were to buy information from somebody, you will pay that person an amount equal to the value you will gain for using that information. So what this 28 means is the amount you are going to pay the guy. So you are not going to pay the guy anything more than $28,000. You're not going to pay the person more than that, because that's whatever information he gives you is going to help you to only get the value of all of this investment up to 28,000. So that is what it is. So 28 is the maximum amount to pay to buy perfect information from any economic forecaster. That's it. This is how you got to work out these formulae. Any question on this? Okay. Because there's one more thing that we're going to calculate and that will finish everything. Okay. So in our next video, what we're going to look at is something we call the expected opportunity loss. Okay. But if there's no question at this stage, just understand something conclusively, and it is the fact that you got to master how to calculate the expected value of perfect information, which is given by the expected value with perfect information minus the one without perfect information. But please note that the expected value with perfect information is also simply called the expected value approach. Note, expected value with perfect information is also called expected value approach. And we use it to decide But then the one without perfect information, we don't use it to decide. We don't decide with it. That one is just to help us to calculate the expected value of perfect information.